If I have two vectors, I might like to know the angle between them. When we talk about the angle between two vectors, we're talking about the shortest way. So the acute or obtuse angle between the vectors, we're not going around the long way, looking at this reflex angle here. We're going the shortest angle in between the two vectors. Here's what we can use to find that. The cosine of that angle, so that's this angle between my two vectors, is the dot product of the two vectors divided by the product of their magnitudes. This derives from the law of cosines. That's where it comes from. Let's try one. I have vectors A and B here. Looks like I'm going to need to know some stuff about those. I'm going to need the dot product of these two vectors. So let's see, I got 2 times -3 plus -1 times 5. My dot product is -11, a scalar, because dot products are scalars. I'm also going to need the magnitude of each one. So we'll do the magnitude of A, 2 squared plus -1 squared, and the magnitude of B, -3 squared plus 5 squared, square root of 34. Okay, why not? Now we have all the pieces, and we're ready to put them in. So the cosine of the angle in between these two vectors is their dot product, A dot B, which we found, divided by the product of the magnitudes. At this point, I have the cosine of the angle. If I want to find the actual angle, what's the value of theta, I can use an inverse cosine. On the left side, I'll get just theta, which is what I want. And on the right side, I'm going to just do the arc cosine of all of this. If I multiply those together, I get 170. And at this point, it's time for a calculator. With my calculator in degrees, I'm going to find the value of theta. The arc cosine of, being careful with the parentheses here, is 147. About and a half degrees. And looking at our picture, that's about right. It's definitely an obtuse angle. It's definitely less than 180 degrees, so that seems reasonable. And I just found the angle in between those two vectors. Look what else we can do with this, what we can figure out from this. If the dot product is 0. So if A dot B is 0, then the entire fraction here is 0, which means cosine theta is 0. Well, what angle has a cosine value of 0? That would be pi over 2 or 90 degrees. So if I have two vectors whose dot product is 0, I know that means the angle between those two vectors is 90 degrees. They're perpendicular. Sometimes we also use the word orthogonal. So perpendicular if neither one of them is the 0 vector. But to take into account that one of them might be the 0 vector, we say they're orthogonal. But you can think perpendicular when you hear that word. And that's just from doing the dot product and not having to go through all the rest of that stuff. On the other hand, if I have two vectors that are parallel, that means everything on the right-hand side, that let's see that if they're parallel, that means the angle between them is 0, right? They're going the same direction. And everything on the right-hand side, if my angle is 0, this is all 1. And if that's all 1, then that means A and B must be scalar multiples of each other. If you think about that, if A and B are going in the same direction, then one's longer, one's shorter, so A is a scalar multiple of some kind of B. So we can tell something about the angle between two vectors just by looking at the dot products.